Hello and welcome to marketing91.com. In this video, we are going to cover the topic on theory of production part 2. Let's start with types of production function. First, fixed proportion production function. In a fixed proportion production function, a technology requires a fixed combination of inputs to generate a desired level of output, and it is denoted by right angle isoquants. Let us suppose that the output at point A1 is 1 unit. The isoquant Q1 passing through A1 shows that one output unit is produced using 2 capital units and 3 labor units. That is, the capital labor ratio is 2:3. With 2 capital units, any increase in labor beyond 3 units will lead to increased output. Output can be doubled by doubling the quantity of inputs. That is, 2 output units can be generated using 4 units of capital and 6 units of labor. Therefore, isoquant Q2 passes through point A2. Ray OA represents a production process, and the slope of this ray indicates the capital labor ratio maintained for any input level. Moving on to the variable proportion production function. In this case, several alternative combinations of production factors can be employed to produce a given output level. It is assumed that there are infinite ways in which the factors can be combined. The common output level obtained from capital labor combination is given by isoquant Q. The isoquant is continuous, smooth, and convex to the origin. Moving on to short-run and long-run production functions. Short-run. A period in which a firm can vary production levels by varying variable factors such as materials and labor, but cannot vary fixed factors such as capital. Long-run, on the other hand, is a period sufficiently long so that adjustment to all factors, including capital, are possible. Short-run production function. According to this function, output can be increased in the short run by altering various factors, with fixed factors being constant. Short-run production, where output can be increased by increasing one variable factor and leaving the other factors fixed, can be explained using the law of variable proportions. Moving on to the law of variable proportion, it is also called as the law of diminishing marginal returns. This law specifies the behavior of production in the short run, where output is increased by increasing the units of variable factors and keeping the other factors fixed. The assumptions: number 1, fixed factors. A few production factors or inputs remain unchanged, for instance, capital in industry and land in agriculture. Second, variable factors, that is inputs or production factors whose supply can be increased in the short run. Third assumption, homogeneity of variable factors, that is, all units of variable factors have the same efficiency. Fourth, state of technology, that is, technology is given in constant. And the last assumption, labor is a variable factor and all other factors are fixed. Moving on to the phases of law of variable proportion. First phase. In the first phase, TP rises. The rise in TP can be divided into 2 stages. Stage 1, up to point A, TP grows at a rising rate and MP increases as well. The TP curve is convex to the x-axis until point A. Whereas in stage 2, TP grows at a diminishing rate and MP decreases. Starting from point A, the TP curve becomes concave to the x-axis. Throughout the first phase, AP increases, although MP decreases in the second stage. It remains higher than AP. Therefore, phase 1 is a stage of growing returns, and at the end of phase 1, AP and MP are equal. Moving on to phase 2. TP continues to grow at a diminishing rate until it peaks at point C, while MP decreases. Here MP is less than AP, and although AP is higher than MP, it decreases throughout the second phase. The second phase ends when TP peaks and remains constant and MP becomes 0. It is a phase of diminishing marginal returns because both MP and AP decrease throughout the stage. Moving on to phase 3, a decline in TP which results in negative MP. The MP curve falls below the x-axis. Although AP is positive, it continues to decrease in the third stage. Moving further, area of operations. The producer should decide the extent to which production is to be carried out and in which of the 3 phases should the producer function. Functioning in the third phase is irrational because the marginal returns in that phase are negative. A producer will not cease production in the first phase of increasing returns. This leaves only phase 2, where producer produces but does not extend the production until the last point of phase 2, because at this point, MP is 0. Therefore, a rational producer will operate in that part of the second phase where MP is positive. Moving on to the law of returns to scale. Now, this refers to a long-run analysis of production loss. There are 3 types of returns to scale. First, constant returns to scale, also called as a linear homogeneous production function. If output increases proportionally with an increase in input, returns to scale are considered constant. Line OE is the scale line that indicates an increase in scale. The distance between successive isoquants is the same. That is, OA is equal to AB is equal to BC. This implies if both labor and capital are increased by a given proportion, output expands by the same proportion as indicated by numbers 100, 200 and 300 against the isoquants. The second, increasing returns to scale. When the increase in output is proportionally greater than the increase in input, returns to scales are considered increasing. When the returns to scales are increasing, distance between successive isoquant decreases. That is, OA is greater than AB, AB is greater than BC. This implies equal increases in output. That is, 100 units for each isoquant can be achieved with decreasing increments of the input. In other words, by doubling inputs, output can be more than double. Therefore, increasing returns to scale can be attributed to the indivisibility of a few factors. And finally, decreasing returns to scale. When the increase in output is proportionally smaller proportion than the increase in all inputs, returns to scale are considered decreasing. When the returns on a scale are decreasing, distance between successive isoquants increases. That is, OA is less than AB, AB is less than BC. This implies equal increments. 100 units in output are obtained by further increases in inputs. Therefore, returns to scale can be measured in terms of the coefficient of output elasticity QE. QE is equal to percentage change in output divided by the percentage change in all inputs. So if QE is equal to 1, returns to scale are constant. If QE is greater than 1, returns to scale are increasing. And if QE is less than 1, returns to scale are decreasing. Thank you.